here. No, let's not do show of hands. Really quick, thumbs up or thumbs down, depending on how we felt about writing that equation. You can just put it right next to your chest just so I can see. Okay, you can also do sideways if you want. Okay, but a thumb at all would be helpful. Up if you felt good, sideways if in, down. Okay, alright. So, we're going to continue working on writing equations like this. That is not something we had to perfect at all today. So we have 2x plus 16 equals 44. 1 times 16 plus 2m equals 44. Okay. So, it looks like a lot of us trying to pull some of the most common answers. 16 plus 2m, that's a common answer. I have a 16m plus 2p equals 44, and a 16 plus x equals 44. Those are a couple of options here. And yeah, that's the majority of what we're seeing. Alright, so the most common answer is definitely this one right here. Right? Can anyone explain to me, just quick show of hand, or raise your hand if you want to explain. Can anyone explain to us where we're getting that equation from? So, remember, Joni has a total of 44 markers. She has one pack that has 16 markers in it. She has two packs that each have m markers. Write the equation or expression to represent this situation.
So we know there's only one pack with 16 markers in it, and then you add the two packs, but you don't know what to multiply that by because it just says they have m markers, so you just multiply it by m, and then the total amount is 44 markers.
Can anyone add on to or want to push back on that explanation? So we have one pack with 16, then we're adding two more packs with m markers, and we just multiply for a total of 44. Can anyone add any more detail onto that, or does anyone want to push back on that? Okay, let me ask this then. I need more clarity. Why is it 2m? Okay, so why is it 2m?
You've got to multiply both of the packs.
Do you have to multiply there?
You know, you could
Add what?
add,
Naisha, Rakai, y'all with us? Focused in? Okay. We could add what? Alright, I want to pause and I want to remind us of something, because this is why I'm pulling on and pressing on this detailed impact today. Lily Kate keeps talking about multiplication, and that's great, and I want us to emphasize that. Why are we multiplying? Why is it 2 times m, right? When I say 2m, I'm implying there's multiplication. I haven't said it, but there's definitely multiplication there, so why is there multiplication there? Well, yeah, it's going to help us find how many markers in the pack, but that's not why we multiply. Why do we multiply? We talked about this extensively on Friday, guys. Go back to what is multiplication? Repeated addition, right? I asked, do we have to multiply? Because here's the reality. Could I say 16 plus m? And then what else? Plus what? Because how many packs do I have? 2 of them, right? See, I'm adding m markers just twice. And now we are explaining, if I'm repeatedly adding m, what operation shows repeated addition? Multiplication. And how many times am I adding that m? Twice. Please do not forget that. Hear me very clearly on this. Intuitively, a lot of students know to just multiply 2m in this case, but they miss when we are supposed to do that later, or they try to multiply when it's not the right time. When's the only time we should be multiplying? When what? Say again. When we're repeatedly adding. We should only have that multiplication when we're repeatedly adding. Or sometimes we'll get into repeated multiplication, right? But don't forget that multiplication right here is repeated addition. So what am I going to do now to solve this equation? Divide? We agree? Naisha, you say no. Why not? You should subtract what? Could you we gotta start thinking about this stuff. We're gonna use it today. Could we subtract 16 on both sides?
Yes.
Yes? Okay. I will go ahead and say this. There's two ways to approach this. There's one that is going to be my recommendation. But Lily Kate, you did say to divide, right? Divide by what?
I was thinking divide, but then you can only do it when there's an exponent on both sides, right? When there's more than one exponent.
Do we divide when there's exponents?
I mean, not exponents, variables.
Okay. I will say this. We could divide here. It's not what I recommend. What would I divide by? And I wouldn't recommend subtracting, but what could I divide by? 2. Do not forget, though, if I divide by one side of the equation, I have to do it on the other side to make equivalent equations, right? It's property of equality. The one difficulty a lot of students run into is they'll try to just divide by here. Is that dividing the entire left side by 2, though? No. You'd have to divide the entire left side by 2. This is another case, right? So I have to divide the entire left side by 2. And you can do that, right? A lot of students get a little tripped up on this and knowing exactly what to do. Does anyone remember, though, what I recommended on Friday instead of division?
Adding or multiplying 1/2.
So notice now I'm going to multiply everything on the left-hand side. And in this case, it's 1/2 because what is that fraction bar? Divided, right? So am I still dividing by 2? Yes. I recommend that reciprocal. If you remember, that's what it's called, right? 2 divided by 1, the reciprocal is 1/2. That's going to distribute, right? Now it's easier to recognize I need to distribute. What is half of 16? 8. What's half of 2? 1, right? So I'm going to make that into a 1. So 1m is equal to, and half of 44? 22. Now what would I do to solve? What's 8 minus 8? 0. Right, we're creating those zeros and ones all over the place, so m is equal to 14. If I look right here, y'all said originally you would subtract by 16. What's 16 minus 16? Remember properties of equality? Don't forget, the whole point of this is 34, 28. The whole point of this is, does this original equation and this equation look different? Are they different though? What does that mean if they look different but effectively they're the same? Or they mean the same thing? They're equivalent, right? That's that terminology we started on Friday, and we want to think about that. So notice again, 2m is equal to 28. Now what would I do? Multiply by 1/2 or divide by 2. I'd still recommend multiplying by 1/2 because what is 2 divided by 2? And what's half of 28? So, could we have done it either way? This is something I want to point out that, and you're going to hear me talk about this heavily throughout this first unit, that there's more than one way to approach these mathematical problems. We teach students a lot of times that there's only one process, one procedure, but if you understand that I'm trying to create what types of numbers? What number? 0 and 1, right? And I'm just making sure I have the equivalent equation by doing it to both sides, it can still work out either way. I know we're on a Monday, so I need to get y'all up to the board so we can wake up a little bit. But hopefully we're seeing, does it still work? Either way. Yes, Mr. Kenny, I'm with you. Great, guys. I'm so glad to hear that. Naisha was getting there. Okay. We're going to do a quick reminder of active collaboration rubrics because we do need that. This will probably be the last time that I remind you weekly. I'll spread it out a little bit more. But we're going to wrap up to use or not to use algebra, and then we're going to get into the dream job salary task where we learn about linear and exponential functions. So remember, these are those lower scores of the active collaboration rubric. I did not get a chance this weekend to share with you the Google Sheet where I've started recording these scores because I was driving 10 hours between Friday and Saturday and it was just a lot. But
Where you went?
my wife and I went to Gulf Shores for a education conference. So we drove down Friday night, were at the conference from 8 to 2, and then drove back 2 to 7 Saturday. It was a lot. Yeah. Anyways, so we you don't want to be here at all. You don't want zeros to twos. To get to a 3, right? Marshall, what is one thing you have to do to get to a 3 on the active collaboration rubric?
Complete assignments.
You got to be working, right? That's not very much. You at least got to work the whole time, right? Jalen, can you give me one more thing other than just working on your assignments in small groups that you have to do to earn a 3? You could take notes, right? During that whole class discussion, you can take notes. Give me one other thing you could do during whole class discussion. Talk, right? In what ways? There's 2 different talking options. Well, we're in whole class. Remember, we're in whole class discussion. What ways can you talk? You could ask questions or share your thoughts. Right? Those are the 2 ways to do that in whole class discussion. So what's the difference between a 3 and a 3.5? What gets you up to that 3.5 on active collaboration? Notice, this is all about the small group to get up to the 3.5. You have to be talking within your small groups. A 3 means you're working. If you've fallen asleep, putting your head down, that you can't even get to a 3. But to get to a 3.5, you have to be talking and actually working with each other to complete the assignments. To get up to a 4 from that 3.5, what changes to get to that 4? 2 of the 3 whole class discussion things. Which means you're going to have to start to talk in that whole class discussion. That can be sharing thoughts, that can be asking questions, the whole 9. 4.5, remember you have to do all 3 of those. And 5, you have to be a leader within that small group. Okay? But here's what we're focusing on. What is math, right? We're really getting into mathematics away from the stats that we did for the first little bit of the school year. So what is math? Patterns and relationships, right? We always want to focus on true mathematics at its core is the idea of patterns and relationships. When solving an equation, what is the pattern? What are we always trying to create? When solving, what are we always trying to create? We already have an equation. We're trying to get to the answer, but look, what are the numbers I'm always trying to create? Zeros and 1s. That's a pattern, right? I'm always trying to create those zeros and 1s. The other pattern is, whatever I do to one side of the equation, I got to do to the other side of the equation to make sure those equations are equivalent, right? That's a pattern. We'll create those zeros and 1s, and we have to use our properties of equality to keep them equivalent. But right now, we need to be doing 3 things. First, you need to notice patterns and relationships. You need to describe and generalize. We're going to get very heavily into that today with the dream job salary task. So we're trying to create and use mathematical representations to find the answer to posed problems. We talked about this a whole lot. We should have notes to help us remember when each representation is useful. What is one mathematical representation we can use? Algebraic, meaning equations. Well, we're still in algebraic. We're going to get there in a second. Algebraic will be equations or expressions or numbers are in the equations and expressions. How about inequalities? We're not going to study those a whole lot right now, but you can use inequalities. Lily Kate already said graphing. Again, remember, I'm personally not going to recommend that you graph by hand. What are we going to use to graph instead? Calculators, once we have what written? Right. The graphing calculator can take the equation and graph it for you, okay? So we got graphing, we got algebraic, we've got verbal, right? Just explaining it. If we can figure it out verbally and explain our ideas, you're there. What else do we have? Pictorial and what? Well, the inequalities, remember, is part of the algebraic. Someone said tabular, right? Tables. And that's one of the really heavy ones. So you have all those options because we want to work up to algebra, but we don't have to. We finished problem 1, bottle and cork. Remember, this is where we should have taken a lot of notes on those different representations. We're working here on problem 2, entry fees. We spent about 10-15 minutes with this on Friday, and we're going to probably wrap this up pretty quickly. I do want to remind you of this. When we looked at option 1, which Roy chose, how many times did he pay that seasonal pass of $240? Once. That was it. Only one time. But before Roy went to the pool once, how much did he spend? $204. He went 0 times and already spent $240, right? And then every extra time he went, it was how much? $10. Whereas Joel chose the second option, 25 ticket for each entry. How much did he spend before he went one time? 0. He didn't spend a single dime. But every time he went, he had to spend more money. How much did he have to spend? 25. So he was repeatedly paying that 25. But they went together all the same amount of times, and at the end, they had paid how much? The same. So we want to find out when is Joel and when, so how many trips did Joel and Roy take so that they paid the same amount? So, will they have the same number of trips or a different number of trips?
Different number.
Look at the wording. They went, throughout the season, they went together to the pool. If it was a different number of trips, it would actually make our job easier. We want to know what is the number of trips that they both went to spend the same amount of money. Does that make sense? Alright, so who has not had a chance to work at the TV yet? Yes, y'all started with the TV. Alright, so group 7, y'all are going to work on the TV today. Let's go with 1, let's do this. 2 and 4, I want y'all to work together on the chalkboard. So that's these 2 groups right here, 2 and 4 on the chalkboard. 1, let's get you on the chalkboard. 3, you'll be up here on the whiteboard. And it's the only group, 5 and 6, I haven't said y'all yet, right? Y'all be on that whiteboard, sound good? And we'll change it up after this problem. So let's get to work, let's try to finish this in 5 to 10 minutes. We'll have a whole class discussion, and then we will move into the next problem. Oh, sorry, I forgot. Make sure you have your understanding check out to turn in. I'm going to have you turn it in at the end of the class today. You can just leave it out. I'm going to grab it from y'all at the end of class. Remember how you're supposed to score your understanding check? Yes, remember how you're supposed to score each question? Yeah. Yep, you're supposed to score each question. Yeah, you can erase all that. Come on, Naisha, Sanaya, let's get to work on this problem. Let's get our work up here. I just told her, I got onto her. Work, let's get to work. You might use something like that. Now, we'll point this out. How many variables do you have once you write this equation? Have you written your equations yet? Oh, no. Say again. You got your variables. So yeah, we have variables, right? Trips to the pool and money paid. We have 2 variables. So how many equations do we have? 2. I might look at my notes from problem 1 because I believe we did some stuff when we had 2 variables for problem 1. But oh, okay. Y'all killing me. Okay, so yes.
Can I just step outside for a second?
Yes. So did we create our table at least?
Yes.
Okay, so how many columns did we have in our table? Do you remember? How many well, first off, do you know what our independent variable was? Did how much they paid depend on how many trips they took, or did how many? Yes, that one. So then their trips was their independent variable, right? 0 trips, 1 trip, 2 trips, so on and so forth. And then we were looking for when they paid the same amount. So I might say, do we use M? So M for Roy and M for Joel. Start to fill that out, and that's going to help you write the equation. Now, you could have also, you don't have to have done the table, you might have just written the equations. Do you remember what equations we have here? Okay, so grab a piece of chalk, let's look at the problem, and let's think about what's happening. Remember, right, how many times did Roy have to pay that initial amount? That $240. So think about that. How many times did he have to pay that $10 each time? Think about what we did in Belgrade to help you. Okay? Yeah.
It don't hurt.
You're on the same problem, right? So, okay? Hey, Joe, here's the chalk. Know that they're with you today. Work with them, talk with them. Let me ask you all a question. Have you, so first off, you're in the number of trips. We need those to line up, right? 0 went here, 1 went here. These 2 lined up here. These need to be in line. What you doing? I might draw lines across it.
Oh, yeah, everything's out
You don't see a pattern here?
Yeah.
What's happening?
1 by 10.
Okay, that's a pattern. So listen, let me answer the question. If it's going by 10 for how much is it going to be for 5 trips? For here? If it's 10 every trip, if we go 5 trips, it's, right? That helps me. When I look at Joel, how much is he doing every trip? So how much would it be if he goes for 1 trip? 4 trips. Okay, that helps me too. Well, I might just pick up from here. Right? Use that pattern though. Hey guys, don't forget to write stuff up on the board.
Mr. King.
Yeah. What's up? What you got? Okay, so let's talk about it. So 0 trips, 5 trips, 10 trips, 15 trips. Okay, so what is C and what is TOT? Well, T is trips, but what is the other variable? What did we write for our second variable? Then we talk about money that they pay, right? But remember, we're looking at 2 different people, so we have to pay the money that and we have the amount. Money that Joel has paid. So when they've gone, actually this is based on what I'm seeing. Joel. When Joel had gone 0 trips, he spent $0. Brownie, you here with us? But when Roy had gone 0 trips, he'd spent how much? Well, maybe parts of it. But when Roy had gone 0 trips, he spent. Now, if we look at, so like every time that Joel goes, how much does he spend? So if you go, if you go 5 trips, how much is it? So if he goes another 5 trips, how much more is he going to spend? I'm ashamed. Okay. When we look at Roy though, he started with 240, but if he goes 1 more trip. So how much more? And another trip, another $10. He gets 260. How much is it going to be for 5 trips? How much is he going to spend for 5 trips?
We not finna write all that.
If he goes another 5 trips, another what? Keep that going and find out how many trips they took. Then start to look at the equation. Okay. What is the CATOT? But
Like a tot, like a tater tot.
no, I don't know. Look, but so C for cost, sure, but we didn't need a total here. We had 2 different costs. We have how much Roy spent and how much Joel spent, right? Okay. So if let's say this, if Joel goes 1 trip, how much does he spend? 25. He goes the second trip, he's spending another. So notice you went from 0 to 5 trips. If he goes for 5 trips, how much did Joel spend? Right? That's a good marker. No, he spent how much? 25, 50, 75, 100, 125, right? So if he does another 5 trips, how much is he spending? Well, how much more is he spending? Because notice I just said another 5, right? So that could work for Joel, but now I need to look at the cost for Roy. If Roy goes 0 trips, how much is he spending? Look at Roy again. He spent 240. Well, not if he went 0 trips. If he goes 1 trip, how much more did he spend? 10 more, so 250, right? If he goes another trip, he's spending how much more? Okay, so if he goes for 5 trips, because you went from 0 to 5, if he goes 5 trips, how much did he spend? He spent 10 every trip, so that's 50 more, so how much does he spend? Not 300, talk about it, let's get to work. If he goes 5 trips, how much is he spending? Hold on, I need to check on this group, I haven't checked on them. If you feel like you have found an answer, start working on the algebra, write an equation.
290.
Thank you. Okay, so y'all have a table, but like, don't remember, it's as many options as possible. We don't just stop, right? We still need it using an equation, right? But you already have the information you need for this, right? That we did. How many times has he spent that 240? 1 time. But then after that, every trip he makes, he's spending how much? So what's he repeating? But these are exactly, okay? Joel started with 0, but how much is he spending every trip? Let's get to work. Alright, what y'all got? But have you worked on the equation yet to confirm it, right? Okay. Now we'll say this is really low, what I would probably do is I might use those equations to also after what you said. No. Never slow down. Do a little extra, right? So use your equations because we do need to do an algebra. Let's write our equations. Think about the bell ringer and use that information. Okay, so how's it going? So yeah, so you want to really quickly why don't skip the zeros? I would probably always use a 0. Okay, start with a 0. Because how much did Roy spend at 0 trips? Look at it. Is that what it says? Roy was option 1. He paid that 240 up front, okay? Okay? But then Roy, let's focus just on Roy for a second. So Roy spent how much more every trip? $10, right? And then if you went a second trip, how much more did he spend? Spend another 10. So he took the same number of trips, okay? But my question then is, so if it's $10 every trip, how much more did he spend over those 5 weeks? So then how much does he add now? No, he spent 50 more. See how I added 5? How much is he adding? Maybe it's 90 in there? So plus how much? It was 10 every trip. Plus 10 is not too bad. Right? Plus 50, right? It was 10 every trip. I'm just going to write plus 50, not plus 10, right? You just said it was plus 50, didn't you? Okay, well look at Joel. How much did Joel spend on 1 trip? Or how much did Joel spend on 0 trips? Did he spend $25 if he didn't go at all? He spent nothing if it was 0 trips, okay? So 0. But if he goes 1 trip, he spends. If he goes a second trip, he's spending. Well, 25 more, so I want so 50. So if he goes for 5 trips, how much is he spending? Like no positive.
It's not all bad.
Notice how about repeating that might be important for writing equation. So we went plus 125 there. So let's keep it going. Let's find out. We get that plus 125 is down. Well, I meant so like 25 there, but I didn't write out what's plus 125. Because if you do another 5 trips, how much more are you gonna spend? There's another 5 trips. How much is he gonna, how much more? When he went 5 trips, how much did he spend? So if he goes another 5 trips, how much did he spend?
Oh, they
Guys, hold up, you're looking at, Joel, right? If we look at Joel, another, how much? Well, 25 every trip, so if he goes 5, there we go. That's a pass. Stop being scared, alright, let's get that table set. So equals M. 25, well, there was something for that 25, right? Because we already did equal, I can't eat Joel, right? 25 what? Because if we use 25 T, what's understood as 25 T? There's the whole line, what is multiplication? Is that what's happening? We were multiplication? Okay, so use your notes from the sheet on that. Solve that system. Guys, how do we get stuck? What happened? No, you didn't.
We were like way down like.
Then why did you raise it all? Did you go by 5? Okay.
Mickey, we're talking about now.
Okay, how much you got here for gold? $0, right? And then how much for 5 trips? Well, every trip, so plus 125, right? If he goes 5 more trips, he spent how much?
16 times 25.
How much more?
We was 16 times 5.
5 trips is how much?
250.
Wait, 5 trips is 5 trips is how much? So 5 more trips is how much?
We don't calculate.
Right? For 250, first off, you have to use the calculator. If he goes, look, right here, no, it's right here. If he goes from 10 to 15, how many more trips is he going? No, how many more trips? How many more trips? 5. And if he goes 5 more trips, how much more is Joel spending? 8. No, how much more? Oh, he's going another 125 for a total of? Now focus on Roy. How much did Roy spend on there? 240. Every trip he spent how much? 10. 490. Look at the sheet, get it out. So if he went 5 trips, how much did he spend? How much did he spend? 50 more. If he went 5 more trips, he spent another 5 trips. 390. Okay, no, we get up to 500. Okay, wait, those, you see how this one being less is now being more? See how they pass each other? This one's less, now it's more. So we just need something in between. Play, just go a little bit more, right? Because if he goes 16 trips, right? How much more is Joel going to spend to go 1 more trip? Okay, so I'm going to try 16 plus 1 trip, which gives me plus 25 to. If Roy goes 1 more trip, how much more is he going to spend?
I feel
Same amount of money, right? How many trips do they each take? Naisha, work with your group. Use your notes to figure out how to solve that system. No, guys, that's not what we did to solve the system. Get your notes from problem 1. We talked about how to solve the system. Maybe look for the words elimination or substitution. Okay? Now let's work on writing the equations. Okay. Did y'all already write those equations? Guys, where's y'all's system of equations, your equations? I don't see any equations up there. We should be writing that up on the board. I need my equations. No! How many times have we had to solve this at least how many ways? 2 ways.
One gotta be algebraic.
One's gotta be algebraic. Look at the notes where we did it algebraically on Friday. Come on. Okay. Whoops. Can I see pen? But here's the thing, that's not solving it algebraically. True, but what are the equations that you could write? We don't know the 16 until after we solve it. 16 does not need to be in there. You look at the information on the sheet. What are the equations we can write from the information on the sheet? Guys, where's y'all's algebraic work? I need to get up, onto the board, and I need to algebraically do this.
Oh my God.
Equation.
There's no algebraic equation. Look at this again. Right? You only have numbers, there are no variables here. I need you to look at Roy, and I need you to look at Joel, and I need you to write equations for their options, and then use your notes to figure out how to solve that system of equations.
So yes,
We
sir.
did 2 different options. Solve that system.
Hey, what page is that, bro?
Yes, sir.
You got mine? He gave us one? Oh, wait, he gave us one.
As long as you submit your excuses for being out last week, that will go away. And then that's a homework assignment that is in the books. This is M5-74, right, and practice. However, you're going to need to watch the videos on YouTube. So if you search my name, there's a whole bunch of videos. The videos are from last Tuesday morning. Okay? So watch those videos to catch up on that. Yes, I figured. Just make sure you work on that. Yeah, don't act like librarians with the whole group up here. Hold on a second. Let me ask you this. Look at this thing. Right here. Look at Joel. Before he even went once, how much did he pay? 240, right? How many times did he spend that?
That's what they said. They wrong.
So 240. Just like in the bell ringer, the first packet of markers had how much? 16, right? Happened at one time. Then Roy is paying how much every single time? So what's happening between the 24 and the 10? They're being but he's repeatedly adding 10, right? How many times is he adding 10? So how am I going to show that he's adding 10 every time he goes? The variable? What's going to happen between the 10 and the variable? Huh? So right here you say you put plus 10, and you put plus 10, and the next one will be plus. What are you repeatedly doing? So what's going to happen between the 10 and the t? Right? And now it's changing how much he pays, so that would be the cost. There's the equation to represent how much Roy was paying. Now look at this one. How would you write the equation for the fact that he started spending $0, and then every trip he spent 25? And then look at your notes what to do with those 2 equations. I'll be in a second. Come on, how's it going over here? Where's our equation? Let me ask you a question. Look at the wording of Roy and Joel. When you look at Roy, how much did he start spending? How much did Roy start spending? 240, right? How many times did he spend that 240? Okay. So what would I do to represent the fact that the 240 only spent once? Think about the bell ringer, right? That's why we did the bell ringer. How many times were the 16 markers? So what did we write? We just wrote 16, so here we're just going to write what? Here we're just going to write 240, right? Every trip. What's happening? He's adding how much? 10. Huh? Not every trip. Every trip was 10, so every 5 trips. Let's do this. No, you gotta use the restroom before class, dude. You would have started with 7. Hey guys, let's go back to our groups really quickly and let's talk about some stuff. and then I'm going to release you to go back into to where you were working. Okay. I let y'all work a little bit too long. I should have pulled you back earlier, and that's my bad. But I need y'all to focus on a couple of details. All right, first things first. A lot of us are creating a table first, which is great. When are tables useful? Why would we want a table? Looking for what? Patterns. A table, remember, is going to help us organize our information. But I want to look back here first, and then I'm going to look at a couple other places. Right here. In this table, this is what I would recommend before just jumping. In this table, this group, and we can't see it, actually I can make it bigger. This group started with how many trips? 0 trips. I would usually, not always, but usually recommend starting with that 0 trips. And so notice we have Roy and we have Joel, the amount of money they're spending, 240 and 0. And then we go by ones to start. At 1 trip, how much has Roy paid? Or how much more has Roy paid? 10 more to get to 250. Then, to go 1 more trip, Roy's going to spend how much more? 10 more. Immediately, what should you recognize about that 10, y'all? It's being repeatedly what? Added. I keep talking about that. We've got to start to recognize that we're repeatedly adding there. Now, we can start, and then Joel, notice how much did he spend starting? 0, and then was repeatedly adding how much? 25 for every trip. So once we start to notice that, we can start to look at a pattern like this. If Roy is spending 10 every 1 trip, every 5 trips, he's spending how much? 50. Speed it up, that's fine. If Joel is spending 25 every trip, and by the way, I would point this out, that 50 is 10. What are we doing to that 10 to get to 50? Times, because we're repeatedly what again? Adding. When I look over at Joel, how much is he spending every trip? 25. So when we go to 5 trips, he's spending 125. Or we could say that's 25 times 5, right? And so we want to recognize that, and we want to use our tables to help us write our equations. So right here, when I look at this equation. Why is there a 240 here? That's how much he started spending, right? Roy spent $240 before he ever got started. After that, what's the pattern? Because tables are great for patterns. What's the pattern for Roy? Spent 10 every time he went, right? How are we going to show that? Because I see a 16 here. And I need to pause and I need to point this out. This 16, is this coming from the descriptor in the task? Is that 16 showing up anywhere here? No. Pay attention. That 16 came because you already solved this once using a table. That's not supposed to be a 16. What's the pattern based on the verbal representation, based on the table? What's the pattern? Plus what? 10 every trip. Now, before we work the problem out, do we know it's equal to 400? No. What do we know it's equal to? M, the amount of money he's paid, or if you use C, it's the cost. We just know that this is for Roy. What are your questions about that equation? We're going to have to do this again, or something similar to this and again in a minute, but we need to recognize when is there multiplication? When there's what? Repeated addition. If you see that repeated addition, we're thinking about multiplication. You've got to start to immediately connect those ideas. So when we're looking at Joel, in a similar way, how much is Joel spending at the beginning? 0. Now I could write that. Do I need to? No, but I could. But then what's the pattern? What's repeatedly happening? It's being what? But what about that 25? It's repeatedly what? Added. Guys, pay attention to patterns, because what is mathematics? The study of what? Patterns and relationships. Those patterns and relationships should define what we see here. So plus what? 25t. Because that multiplication is repeated what, Hayden? Hayden, what's that multiplication? Can someone help him out? Repeated addition. So Hayden, what is that multiplication? Right? Phoebe, what's that multiplication? Naisha? Okay. Desiree? Do not forget that as soon as you see repeated addition, we're thinking multiplication. That's not the only repeated thing in mathematics, but when I see repeated addition, I think about multiplication. Every time. And so that's also equal to m. Now remember, we have how many equations here? 2. What are the options to solve a system of equations like this? Okay, you doing it algebraically, substitution or elimination. What would be the better option here? Why do you say that? Can anyone add more clarity to that? The 25 at the end of the equation? We should have written this note, and I actually watched the video this weekend to make sure it was in there. If you did not write this down on Friday, when is substitution the best method to solve a system of equations? Anyone know? Because we need to go back to these details. We use substitution. So we're going to use substitution to solve a system of equations when one variable equals an expression. There's other times you can do it, but that's the easiest way. When one variable is equal to an expression. Right here, what is m equal to? So what can I do with that 25t? Say it a little bit more mathematically for me. Substitute it in for what? M. So Traylon, what are we going to do with this 25t here? Substitute it in for m. M is literally equal to that thing. So, do not forget that. Substitution is great when one variable equals an expression. When do we want to use elimination, though? We should have had that in notes. When we have the equations in standard form. Once you finish taking those notes, go back to your groups. I rewrite those equations and solve that system, and then we'll come back together in just a couple minutes. Alright, so just a couple minutes to solve that system. Let's get to work. Or just sit there. No, go back to your stations. Yeah, to the vertical surfaces. Does that make sense for those equations now? Yes, Caitlin, you with those?
You must get in the same
Okay. Trey, how you get over there? Come on, let's get up, let's get moving.
Are you going second day?
Yeah, bro.
It's okay, we'll never get that page.
For sure. But it's a notes thing.
It is. Well, I mean, everything can be notes. We're not going to get to that concept. Come on, let's get to work. Let's go. Let's go. Come on, Mickey. Wake up for me. You stand up, move around, I'll help you wake up. Come on, Desiree, Rakai. What's up? Push baby. That's not ideal.
Sales makes out loud. That's what you look at your father. Those try hard.
That is not 10.
Don't for real, that's not.
I didn't say that that's not a 10 there. That is not just 10. Because literally means
That's not what we're
T plus T plus T. It's not just 10. It's 10 T's being added, right? So what am I actually supposed to be doing? Subtracting 10 what? I need to be subtracting T 10 times. Be careful about that. That makes a huge difference, doesn't it? And so if I subtract 10 T's over here, what do I need to subtract over here? 10 T's. No. Because I know, but that's not saying. If I just do 25 minus 10, 25 T
I'm sitting here changing.
I can't actually add
Look, I was sitting here like this, like this, like
If you do not get T, that is a procedural error. You may recognize that it's supposed to be a but you just put that is not 10, we just subtract it.
You see
That makes sense. So we want to be careful with the mathematical side of it. Rakai?
Yes.
Alright, come on. Let's make sure we're actually working together, okay?
We're gonna actually work together.
Really, hold on a second. Did you subtract 10 from both sides of the equation? Maybe. But I want you to look at this again. First off, where's this 25 coming What were the equations again? Price of one ticket, right? So what's happening to that 25? It's all written up there. 25 what? Does that make a difference? 100%, right? Second off, when I look right here,
He don't know we not
whatever you do to one side of the equation, you have to do to the other. I will say this, I know what you're about to write. It's not one of those mathematical sounds. Continue working, you're going to get probably the right answer, but you need you to pay attention. We have a whole class discussion about why it's not really minus that. We're going to talk about it. Okay, let me ask you this, and I'll leave you alone. 10T. What does that 10T really mean? It means I'm adding 10 T's, right? Are you subtracting 10 T's right now? No, I'm saying right here, are you subtracting those 10 T's? Or are you just subtracting 10? Now have you found out how much money you're using it? Oh yeah. So you have substitute that 16 back in, right? Cody, that's right. See all paying attention to that.
No, I'm sorry.
Y'all look stuck. What's going on? Well, let me ask you this. What method do we say we're going to use? Substitution. Okay. If M is equal to M is equal to this, what can I do with 25T? Think about what you just said. We're going to use what? What can that 25T be substituted in for?
If M is equal
The 25T. What can 25T be substituted in for?
Don't worry about us.
Does M equal that?
Yes.
Hold up. Is that the equation you wrote over there? No. Equals what? Equals M. We don't know the 400 yet, right? The only reason you knew the 400 was because of this right here. You didn't know that 240 yet. Because we have how many variables?
I think.
So what do we do if we have 2 variables?
Okay, so it's whatever you
We have one equation and 2 variables. If we have 2 variables, we need another one. Yeah, what was the other equation you wrote? You have an equation for Roy's cost. What about Joel's cost? Equals what?
I was in the hour and I had my Duke, I was trying to piece it up, right?
Oh, I didn't even ask why it's 25T.
Somebody said it.
Okay, because you
I
just
swear to God,
Kind of, how? Using what? If m is equal to 25t, what can you do with that 25t?
Yeah.
Oh,
Yeah, they don't even like that. Bro, I said,
circle that
it's
25t
sloppy.
for me.
Y'all had to.
N is equal to that thing, so what can I do with 25t? Look at your other equation, what should I do? Well, you're pointing at that thing.
You didn't do that. Who did?
Plus 25.
Actually,
If
I did.
m is equal, let me ask this, if m was
I
equal
thought
to
he
30,
did. Well,
what would you do with that 30?
he did that top part.
If m was equal to 30, what would you do with that 30?
He mentioned.
Girl, you wrong. You ain't doing it. You could come up. I did it.
Yeah, but let's say I wanted to solve this equation, if m is equal to 30, there we go. What are you using? I know, but what are we using? We use an
I can't personally.
What are you using? It's an S. Oh, substitutions. Come on now.
Come on, guys.
Yeah.
Ain't it right?
Let me ask you this. When we solve the equation, what are we trying to create? Okay. This was your 0, right? If you divide by 15t, are you creating a 1? Because it's 15 times t. What do you need to divide by? But I want to solve for t. So I'm dividing by what?
Well, we got one number.
And 15 divided by 15 is... So what's on the right-hand side of this equation? 1t. And what's it equal to?
You do I told you that. I'm not talking to you. I'm not talking to you.
Thank you. Thank you. Thank you. Grab a seat. Go back to your desk. We're going to talk through this a little bit because I'm seeing some common errors that we definitely need to address. Okay? All right, grab a seat. Okay, listen up. I'm going to need you to take some notes as we talk through some of these things for number 2. Hey. Hey. Guys, pause. Jose, go back to your group. Thank you, sir. First off, and I get where this mistake is coming from. Until you had done this table, did you know that they were spending $400? No. Before you did the table, you did not know the 400. So you do not know originally what 240 plus 10t is equal to. We need to use a variable. Now I need you to hear me clearly on this. Once again, if you have one variable equal to an expression, what's a great option to use to solve that system? Substitution. If m is equal to 25t, Jayla, what can I do with that 25t? Did you talk about this within your group at all? Because I was over there and we talked about this. Say again? Yeah, if m is equal to 25t, what can I do? Substitute what? Substitute what for what? Say again? Well, the 25t for m. Okay? Mickey, if m is equal to 25t, what can I do with that 25t? Say it again. Substitute it. Okay? Marshall, why can I substitute that 25t in for m? I think this is something we're missing. Not necessarily just you, but we as a class. Not sure?
What do you mean?
Why can I substitute this 25t in for m?
Because it's already equal to.
Because they're equal. Guys, if things are equal to each other, they can be substituted in for each other. So I'm going to point this out. Jose, right here. Do you know what I could substitute 240 plus 10t in for?
What?
Do you know what I could substitute this 240 plus 10t in for?
M
Why can I substitute it in for m?
is equal to M.
Because it's equal to m. Any expression equal to a variable, I can substitute it in, guys. If I have a variable equal to an expression, I can use substitution. Now, that means if we substitute 25t in for m, we get this equation. Now I need to come over here and I need y'all to pay attention to this. This is hands down one of the most common mistakes. Actually, please write down your equations on a notebook sheet of paper or the bottom of paper or something and make that note to yourself, right? That 25t can be substituted in for m. Because of what? Why can we substitute it in? Because they're equal. Sorry, it's so small, I should just erase stuff. But we can substitute 25t in for m because they are equal. That's it. If a variable is equal to something, we can substitute that something in for the variable. So we can substitute 25t in for m because they are what? Equal. Please do not forget that. Okay. I have rewritten this group's equation up here. Okay. Here's what they did. And I talked about this with a couple of groups. They subtracted 10, they subtracted 10. And I will say this. They got 240 equal to 15t. That equation is correct. What they did to get there is not quite mathematically correct. Can anyone explain based on conversations we had? Trayana? Remember, guys, active collaboration. I'm looking for discussion here.
They forgot to put their T with the 10.
Do we need that t with the 10?
Yes.
Why?
Doesn't cancel out.
It's not because it's not just 10. It's not mathematical.
It's not mathematical, it's not just 10. Okay, I need y'all to remember this. Pay attention here. When we say 10t, 10 times t, what does that really mean? It means we're adding t how many times? 10. Is this taking away 10 t's?
No.
It's just taking away 10. So what would I need to put here to indicate I'm taking away t 10 times? And now, what is 10t minus 10t? Guys, take the time to write that 0. First off, that's evidence of understanding that you put that 0 there because what are we trying to create when we solve those equations? We're trying to create zeros and ones. What are your questions about why we need the minus 10t there? Okay, you need that minus 10t there. We're about to do that. We're not quite done, but we're about to do that. So good question. Now I want to look at this. This is the second most common mistake that SE students make. Alright? They got down to 240 equals 15t. And now they have equals 16t, but aren't we supposed to have that t, the number of trips, equals 16? Not a 16t there, because what does 16t mean? That I'm repeatedly adding t how many times? 16, so we need to pay attention to this. I talked about this with at least one or two groups. Look right here on the right at this equation. What should we be doing? they have, huh? Okay, not quite 1/2. We'll talk about that in a second. I'm okay if right now we say division. What should we be dividing by? Say it again. 15. Remember, I needed that t up there so that I'm taking away 10 t's. But right here, 15 is being multiplied by t. When there's multiplication, I need to use division. But what am I trying to create when I divide?
1 to 0.
Well, for the division, I want a 1. Remember, adding and subtracting is 0. Multiplying and dividing is a 1. Okay. So what do I need to divide by here? Just 15. Because what do I want to be left with on the right-hand side? 1 what? T. Now notice 1 times t is t. I divided by 15 on the right-hand side, so on the left-hand side I'm only going to divide by 15. And what's 240 divided by 15? See how that gives me the 16 is equal to t? So we only include the variable, and I think that was some of the confusion because of the discussion I had here. When's the only time we're including the variable? When we are... Right. Because this multiplication, right, means I'm repeatedly adding 10 t's, but I'm taking away 10 t's. I'm subtracting t 10 different times. But I'm not trying to add or subtract my t's here. I'm trying to get divide by 15 to create that coefficient of a 1. Okay? Take what notes you need to on that. And that's about to be our last thing algebraically there. And we are going to look at this graphically because y'all missed out on a chance to do this graphically. I will make this note here as a final thing. I wouldn't multiply by 1/2 here. Does anyone know what I would multiply by? One 15th. Remember how you said earlier to divide by 15? So this is 1, what's the fraction bar? Divided by 15. So Jacob, we only multiply by 1/2 when we're multiplying by 2 because it's 1 divided by 2. If I'm multiplying by 15, I'm going to divide by 15. 15 divided by 15 is 1. So I'm left with 1t. And that'll give me the same answer, okay? Get your notes down for that algebraic method, making sure that we pay attention to those details, and then pick up the calculator and create a graphing page on the calculator. Come on now. Okay, does anyone need me to remind you of how to add that graph page while my computer is going slow? Yes? So remember, hit the home button first, top right hand corner. And then what? And then you can either do B for graph or you can hit new doc. Okay, so home, I do new doc, and then what kind of document do we want to create? Graphs. Now, I do want to point this out. In this problem, do we have this in function notation where the output is equal to something? If we let m be my output, 240 plus 10t, y equals 25, well I should use x. Is that function notation or using y equals? So can I do f of x equals? You can do that here. Okay? So just type in the equations as 240 plus 10x. We need to actually have that graph page open to be able to do it. And then what are we going to do? Press enter. What do I need to do to create a second equation or put a second equation in? Menu. Then graph entry /edit. And what can we always use? Relation. But because we have y equals, this time we can use function. And so 25x. Notice I only see one of those equations. Anyone know why I only see one? Because it's not zoomed out, right? So remember, I would change my window settings and just play around with it. So again, menu, window, settings. Can we have negative trips? No, you can't go negative number of times to the pool, so maybe like -3 or something. I always do a little bit negative so I can see my y-axis, right? Remember, y-axis is when x equals 0. Maybe 20 trips?
Can you slow down, please?
No. What do you need me to do? Go back through.
Restart.
What? You haven't created any equations yet.
Man, I have. I just. What you put for the second one?
Remember the 25x. Remember how that was, we had Roy and we had Joel's trips?
Yeah, but how? All right, now how do I make another one?
Good question. What's the button we always press? Start with menu.
Or then I go to graph interselect edit
There you go.
relation.
You can do relation, but remember when it's y equals, you can use function. So it's either one.
All right, okay.
Okay? And don't forget that f of x is equal to y. So you just type in the 25x when you use function. All right, but then go back to menu for the window settings as well. All right. Probably not going to owe money for the y value. And now we already know the final answer, like how much money are they spending? They're spending 400 at the end. But before you solve this problem, would you have known that 400? No. So what would have maybe been a y that would have made sense? It's like I can't even see the Roy's cost at all, or equation, but what did Roy's cost start at? So I need to make sure that that y is at least more than what? 240, right? So I'm going to go y max, maybe like a 300. Ah, I can start to see my equations now, or my lines. I did not change the scale at all. And remember, my x-min and x-max, I just did a -3 for the minimum x. Okay, let me just pull it back up. Minimum x of -3, maximum x of 20. And I changed that y max because I knew it had to be more than how much Roy started out spending. Now, was that 300 enough when I look at this graph? What am I looking for? What's that mathematical term? Point of intersection, right? We want to keep that in mind, so it's going to help us in a second. So, knowing what we know now, what maximum y value should we at least do? I'll come and look at it in a second, but remember we know it has to be more, it has to equal 400, so I'm going to go 450, type enter, work with each other to find that point of intersection. Who said theirs looks weird?
Everybody.
Why does yours look weird? Guys, 25x. Alright, we got 5 minutes. Make sure you type 25x in there, not just 25. Okay, so how are you going to find that point of intersection? But remember, it's a menu button. There's something on our menu. How are you going to go?
I gave up last time.
Ain't it trace?
Don't. Not trace. What are you going to try to do with your graph?
Analyze the
You're
graph.
going to try to analyze that graph. Come on, help each other use that calculator.
Are you going to zero minimum maximum?
What are you trying to find? A point of what?
Intersection.
Okay. What's up? Look at the 2x in there first. Not 25. You put 2x, not 25. That's fine though. So what are you going to do at this point? Okay. You already have some of those. But that's fine. Just leave it as is for now. Come on, what do you need to do from here?
What you got?
But, oh, you just zoomed out. Don't do that. The zooming out is what's going to make this hard. That's why I want to move That's why I went like, 10.
was thinking about stuff.
Yeah, you can now see it more clearly. We can change that later, but how are we gonna find that point of intersection, guys? Who's that? Sit down. Alright, guys, hey, once we have these lines, once we have our graphs, ladies, I'm teaching. Once we have our graphs on there, what can we do? What are we trying to find? Point of intersection. How are we going to do that using the calculator? Menu, always analyze our graph. We're trying to find a point of intersection. Shania, what happened to your calculator? Okay? Don't forget lower bound. What do we need here? No, what do I do? What does that mean to have a lower bound? It just has to be to the left of that point of intersection. That's it. So we're going to hit enter. It asks for an upper bound, so it needs to go to the right. And then I'm going to hit. What am I going to hit? Enter. And so what's our point of intersection? 16 trips was how much money? 400. Is that what we found both times for how much they spent? Please hear me. I know that the technology and the graphing calculator is newer for us and we're not super used to it. Once you get comfortable just graphing those lines, finding a point of intersection, guys, this goes so fast. So fast. It is hands down faster than a table. Probably not quite as fast as doing it algebraically, but it is easier than doing it algebraically, so it has its benefits, okay? So, please bring that with you tomorrow. Whew, that should not, guys, listen to me. Pause. I have not released you to pack up yet. We've got to move a little bit quicker tomorrow, get that third problem done. You have no new homework for me, but I do need your scored understanding check out and put it together on your desk so that I can collect it. If you have the homework assignment to resubmit or to turn in for the first time, you can go ahead and get that out. Can you what?
What is that?
You alright?
So, let's have. Please note your assignments, there's nothing new, but you need to complete or fix the assignment here. For the fixing your assignment of this, I'm going to cap that. It has to be turned in on Wednesday. Scoring your assessment is due today. If you don't have it today, you can turn it in tomorrow, but it's always what % off? 10% off every day it's late. I feel like there's been some good learning today, but what are all of you? Capable of more. Don't forget, chase after greatness. You're always capable of more. Huh? Just with it as well. You already did your corrections? You got some stuff turned in? Is it ready?
No, not ready.
If it's not ready, don't turn it in.
Why would you call me that?
Correct. And that's
Let me see.
Thanks, sir. Food or